Welcome to Mimi's Math Channel. Today we will discuss solving systems of equations by elimination. So my first example shows two systems that are linear. And what you want to do is you want to decide whether or not you want to eliminate the x variable or the y variable. What I would do is I would multiply this -6 by a +2. Why +2? Because when I'm trying to eliminate, I want to use the inverse. So let's go ahead and rewrite this. 2 times -5, and notice I put the parentheses around all three terms because you have to distribute to everything. So that's what I'm doing right now. I'm distributing and I'm rewriting. So 2 times -5x is -10x. 2 times -6y is -12y. And that's set equal to 22, which is 2 times 11. And then I'm just going to rewrite what's currently there for that system. -10x plus 7x is -3x. My whole goal was to eliminate one of my variables, so I decided to eliminate y. And then 22 minus 1 is 21. Now I'm going to divide both sides by -3, which leaves me with x being -7. So when you are solving a system of equation, you're trying to put your answer form as a coordinate. So far I have my x, and that's going to be -7. Now I have to find my y value. And for my y value, it doesn't matter which one of these systems I use, whichever one is easiest for you to use. You don't even have to use those. If you rewrote it over here and you wanted to use that, you could do that as well. So what I'm going to do is choose this 7x plus 12y equals -1, but instead of 7x, I'm going to replace that x with this -7 that I just said. So -7 plus 12y is equal to -1. My whole goal now is to find the y, so this is -49 plus 12y is equal to -1. And now I'm going to add 49 to both sides because that's the inverse. So I want to cancel it out on the left-hand side, which leaves me with 12y is equal to +48. 48 divided by 12 is 4. So my y value is 4. So this is my answer. For example 2, I have another linear set of systems, and it really is up to you how you want to rewrite this. I personally want to rewrite it where both my x's and y's are on the same side. So since x is already on this side on the top one, I'm just going to move that -6y over. And anytime you move a term over from one side of the equation to the other, you have to change the sign. So this is going to become +6y. And since I'm leaving the 6 on this side, I don't change the sign. And on this side at the bottom, I want to go ahead and line it up. So I have -4 over 3x. I want my y to be next, so I have to move it over, -y. And I want to move that -2 on the other side, so that's +2. And now what I need to do is determine which one do I want to get rid of. Do I want to get rid of my x's, or do I want to get rid of my y's? For me, since this y is by itself, it would make sense to try to get rid of that. So I'm going to multiply all three terms by 6. Again, why 6? Because I currently have a +6. I need to make this bottom one a -6. So I'm going to distribute all the way over, and I'm going to rewrite 2x plus 6y equals 6. Notice I didn't have to touch that top system. The bottom one, what I'm going to do is this 6 and this 3, if I cross simplified it, that's going to become a 2. So 2 times -4 is -8. And then I have 6 times -y, which is -6y. And then 6 times 2, which is +12. My whole goal is to eliminate. And so I'm eliminating my y's, and I'm left with -6x is equal to 18. And I'm going to divide both sides by -6, which leaves me with -3. So far, I have my -3 for my x value. And now I just have to find my y value. How do I do that? It does not matter, again, which one I substitute in for. I am going to use, I'm going to use this one since the y is already by itself. And so what I have is negative 2 minus 4 over 3 times the x is negative 3, and all of this is equal to y. Negative 2. Now you can do this one of two ways. If you see that the numbers are the same, you can just go ahead and cross that out, and that becomes negative 1. So negative 1 times negative 4 is positive 4. And set that equal to y. Or you could have said negative 4 times negative 3, which is positive 12, divided by 3, which is still positive 4. So it's up to you how you want to do that. And now once I simplify, y is equal to negative 2 plus 4, or 4 minus 2, which is 2. So my systems, when I'm solving it, this is my answer. Again, I need both x and y. Now for this last example, what I have is a quadratic as well as a linear system. And when I'm finished with this, what I'm going to do is show you how to check your answers by graphing it. You can either use your graphing calculator or Desmos. If you use your graphing calculator, you're going to have to rewrite it where y is on a side by itself. All right, so the first thing I would do is I would rewrite these systems, because I noticed that first system has an x squared term, but the second one doesn't. The second system has an x term, but the first one doesn't. So this is what it would look like using a 0 placeholder. I would have x squared plus 0x minus 10y, and I would go ahead and move that negative 40 over to the other side, which means I have to change the sign. So it's now positive 40. And then on the bottom, I don't have an x squared term, so it's going to be 0x squared plus x minus y is equal to, and I don't change the sign of 4 because it's already on the correct side. Now what I want to do is determine which variable makes sense to get rid of, the x's or the y's. Well, for me, it makes sense to get rid of the y's. One of my y's is a negative 10, so that means the other one has to be a positive 10, which means I have to multiply the entire system by negative 10. So that's what we're going to do. And once I do that, I have to distribute to every term that I see, including after that equal sign. So that's going to look like x squared plus 0x minus 10y is equal to 40. So on the bottom, that's 0x squared minus 10x plus 10y is equal to negative 40. Now I want to simplify going downward. Well, x squared minus 0 is simply itself, x squared. And then I have negative 10x. The y's go away. Set equal to 40 minus 40 is 0. At this point, I want to take out the greatest common factor of x. And I'm left with x minus 10 is equal to 0. And then I use the zero product property, which says to take each factor and set it equal to 0 and solve for x. So this one I've already solved for x. X is 0. Here I have to move the 10 over. So if I add 10 to both sides, that's the inverse, x is 10. So I notice that I have two answers. So in one case, when x is 0, what I want to do is go back to one of the systems, and it makes sense to use this one. That one's easier. So once I place a 0 in for x, minus y is equal to 4, and I try to solve for y, all I have to do is just divide both sides by negative 1. So y is going to be negative 4 when x is 0. So that's one case. And then the other case is going to be when x is 10. Remember, that's what I said over here. I'm going to substitute it in using the second system. So 10 minus y is equal to 4. Well, this time I want to subtract 10 on both sides because I am taking the inverse of it. And then I have negative y is equal to negative 6. I want to divide both sides by negative 1 to get rid of this negative in front of that y. And y is positive 6. So I have the answer for my linear quadratic systems. It is When x is 0 in one case, it's -4. When x is 10 in the other case, it's +6. And as I stated before, I was going to show you using Desmos. If I were to type that in, both systems, and you can rewrite it if you wanted to, but I just wrote it exactly how it was. What I'm doing is looking for the points of intersection for the red and the blue graphs. And I see that in one case it's 10 and 6, and the other case is 0 and -4. So that is how you solve systems of equations using the elimination method. I do have a video out there solving systems of equations by substitution as well. All right, that's it. Like, subscribe, and have an awesome day.
Subscribe.